So this is the first in a series that attempts to describe the three most common three-dimensional coordinate systems. So we're going to start with 3D Cartesian and then go to cylindricals and spherical. So we have Cartesian and 3D. And the Cartesian system, like the 3D system, is similar to the Cartesian 2D system, and it has components x, y, and z. And we can begin by drawing our major axes. And we label x, y, and z. If you can recall the two-dimensional system, where we have only x and y. So now how do we start describing a point in this system? I think it's important to begin by understanding the planes in the system. So we want to define the planes of the system. Hope you can see that. Maybe get a little bit darker color. This plane here, sort of like the floor of the system, is the xy plane. And we get that from the two major axes that compose these little back walls here. So the xy plane. Then we have the zy plane, which is sort of like this back wall here. You can imagine a room. This would be a back wall. So we have our zy plane. And this will be important when we're understanding how to get some of the components in the systems if we understand the planes. So we have this third plane, and it's called the, put it right here, xz plane. It's just made up of these major axes. So we have to find our planes. We have our xy plane, our zy plane, and our xz plane, sort of the side wall. So now we can go back to our axes. And remember, this system is the x, y, and z. And so say we have a point. It doesn't matter, just any old point. And we have placed a point in this system. So how can we describe this particular point? And we're going to use a position vector to describe this point. And I'm going to call this position vector r. So we're defining r as some distance to the point from the origin, as where this particular point is, and it has a magnitude and direction, so it's vector. And this point is at location x, y, and z. So how do we define this vector r? So we can begin by projecting this point into the xy plane. And something that looks like that. And this particular point from, well, the distance from the point to the origin, the projection of the point from the origin in the xy plane has a special name, and it's S. And if we recall from the two-dimensional system, something similar where we had a point and a position vector, and it's S, and it had points x, y, and an angle phi. The same holds true in the three-dimensional system. We still have our xy plane, we still have our S, and we still have this angle from the x-axis to the position vector called phi. And so now, where do these components come into play? So x is the magnitude in the x direction. So we're going to go some magnitude x in the x direction, and that will give us our x. And then we go some magnitude in the y direction, and that will give us our y. So we have x and y. And we go some magnitude in the y direction. It sort of follows a projection line. In the z direction, and we have our z, and that gives us x, y, and z. That only told us about the magnitude in those directions. Where do we actually get the direction? And if we remember the definition of a vector, we know that it has both magnitude and direction. So we get a direction from something called the unit vector. So it has 3 unit vectors because it has 3 components. And you have x hat, which is simply a vector with magnitude 1 in the positive x direction. So it's parallel to this system. Some people like to draw it here on the actual axis. And then we have our y, which is the same principle. It's a unit vector with magnitude 1 in the y direction. It's called x hat. And some people like to draw it here just to see it a little better or understand a little better. And we also have finally the c unit vector, which is magnitude 1 in the positive z direction. You can draw it here as well. And so that tells us the direction to go for our z component. And so if we put them all back together, we have, it's kind of jumbly, we have x hat, y hat, and z hat. And that describes those are all the components we need to describe our position from the origin to the point. So we can define our vector as x hat plus y hat plus z hat. And that is Cartesian system.